Hi and welcome back, and in today's video I wanted to talk about something a little bit different. So we've all know about the Intel issues with the 13th and 14th Raptor Lake processors, and what I wanted to do is do a little video just to help you to not only update your BIOS if you're having issues with that, but also to get the very best performance out of your processor and put some safe limits by undervolting it with the Intel Extreme Tuning utility. So I'm going to show you exactly how we do that. I'm going to show you the before and after results. So let's jump straight in. Okay, so I have an i9-14900K, and you probably have a similar processor, a 13 series or a 14 series. If you're watching this video, I would expect that you've come here to obviously look and see how you can improve the performance following the latest update on the BIOS. Now, you would have had to have been living under a stone to have obviously missed the controversy surrounding what's been going on with these Raptor Lake series processors, and the issue essentially was caused by a couple of things. So the first issue was that there's been an oxidization on some of the processors in the early manufacturing stages, and I would certainly recommend checking out channels such as Gamers Nexus, who cover this quite significantly if you're wanting to find out the history of and some more of a controversy surrounding what's happened with regards to that. So the second issue surrounding the processors is that it's a bit of essentially ping pong that's been going back and forth between both Intel and the motherboard manufacturers initially. Many gamers were experiencing crashes during games, and it was essentially coming up with a message saying, essentially relating to a memory error, which seemed to be attributed to the graphics cards. So obviously many people then complained to graphics card manufacturers. We then investigated driver issues. It then came back to the processor being at fault with regards to this particular issue. The conversation then went back and forth between Intel and the motherboard manufacturers, who were essentially allowing untethered power limits to run through the processors, or allowing them to exceed what Intel's recommendations were. Now, once again, it's covered quite significantly by channels such as Gamers Nexus and J2Sense, and if you wanted to get a bit more about the history surrounding what's gone on with that, I would certainly recommend checking those two channels. However, going back on to what we hope to achieve here today, obviously you've potentially now applied the BIOS update in whichever motherboard you have. I have an Asus TUF Gaming Z790 Wi-Fi Plus. I personally haven't had any issues since getting the i9-14900, because it was literally only a couple of months ago, and I managed to essentially tether down the power limits on the processor to drop temperatures. I did actually initially upgrade to a 360 AIO in reaction to the high temperatures, thinking it was actually the 280 that was at fault. However, as it transpired, it wasn't. And it actually turned out to be the actual Intel Boost technology, and allowing the processor to run at its rated 6 GHz speed. Now, we're obviously not going to be running the processor at 6 GHz speed. That's potentially part of the issue as to why this is occurring. We certainly could, and it will obviously then push to quite high temperatures on the processor, and the Intel thermal velocity boost will essentially drop down the processor in accordance with it hitting the maximum, which will probably be around 100 degrees. There is a limit of 100 degrees on the processor, and as I said, it will automatically knock down when it hits certain levels. So what we're going to show you today is using a tool called Intel XTU, which is the Intel Extreme Tuning utility. Many people will say, why are you using Intel XTU? Why don't you just set the underclock on the BIOS? Well, that's fine. However, there's a lot of people out there who like the flexibility to be able to change profiles, and also just want a really easy way of doing this. Now, what Intel XTU does offer you is a very easy way of undervolting your CPU. Rather than having to go back and forth into the BIOS, running benchmarking tests, running stress tests on the CPU, it essentially will allow you to do this in a very easy way. So what we have on the screen here, we have Cinebench R23, which is one of the essentially best standards in testing your processor. And you can see here, before even starting running the test, I don't expect it to reach the same score as what we have on screen here, which is why I've run the score prior to starting the video. I have OBS running and I have it recording directly onto the PC in the background, so that's obviously going to have an impact on processing performance. What I also have open here is just to show you hardware monitor, and this is now running Just in the background you can see obviously that the temperatures are nice and low. I said run over 360 IA over room. Ambient temperature is around 25 degrees in the room. And it's just going to give you a demonstration as to what exactly is happening. Now you'll see for the eagle-eyed view that there is an undervolt set on here, and I'm going to show you how to do that in a moment. And there's a couple of other settings that have been tweaked as well on here, which will just essentially bring things nicely into line. Now the issue that was plaguing the Intel processors was that the VID max was basically exceeding 1.5, sometimes 1.6 on some processors, and obviously that essentially would lead to degradation, and it would lead to failure of the processor at some point, or even if you imagine almost like the processor is silicon, it's a degradable element. And as I said, with such high power levels running through it consistently, it will degrade and it will start to show in performance. In order to bring that performance back up, you would have to run higher voltages than that through it to essentially keep it going until it eventually would fail. So we're obviously going to concentrate on making sure that we have the best possible configuration for this processor here today. As I said, this may vary depending on your processor. If you do have any signs of degradation, and in other words consistent crashes, blue screens, I would certainly recommend taking advantage of the RMA process with Intel. If they have extended that by 2 years now, and as I said, better sooner rather than later to set that ball rolling, get a new processor, and when you do receive a new processor, ensure that you do make sure that these limits are set in place. Okay, so as said, we have a score of 4213. There were a couple of processes running in the background, as said when I actually ran this test just before starting the video. On a 99-14900K, which is undervolted slightly, you would expect to see around 40,000. You probably found if you have run Cinebench R23 and you've applied the Intel default settings, which it does prompt you to do when you've updated your BIOS, you may see that score is significantly lower. It may be around 35,000-36,000, and obviously we want to try and achieve the very best performance from a processor. Essentially that's what we're paying the money for. Okay, so I'm just going to run the test again. It may be slightly tanked from this figure. I would imagine a figure around 39,000 because we do have OBS recording in the background recording this video. So I'm just going to start that off. I'm then going to bring the hardware monitor just back up so you can see exactly what's going on with the temperatures just here. Now you can see that the package temperature immediately hits 83 degrees just there at its highest point, which is still high but it's acceptable. We do have a limit set for Intel thermal velocity, and when it hits 85 it will drop the performance down of the cores that are boosting. So as predicted, it's a score of 39,628. It would be over 40,000 if I didn't have these processes running in the background, but it's still high in terms of temperatures, and obviously we don't want that. Okay, so moving on, I'm just going to show you next the Intel tuning utility and what we can do to change things in there. Okay, so in this section we're going to be looking at the Intel Extreme tuning utility, but there are two things that you're going to need to do in order to run Intel tuning utility. You may receive a warning message when you do download and try and run the software saying that Intel virtualization technology is enabled. Now you will need to disable this in your BIOS. Now as said, I'm using an Asus motherboard here, and the easy way of disabling the option is simply to search the option and then type in virtualization, and it will come up with this box, and you simply just disable it, and then you would then save and accept changes. The other change we need to make in order to actually undervolt our processor using the Intel XTU, we also need to make a change to the BIOS by disabling undervolt protection. Now once again this should be found using the search option, which will be normally at the top, the BIOS options, and if not then you may find it under the extreme tweaker section under advanced options, and you can see here that undervolt protection is disabled on this particular example. Once you have those two options selected, accordingly, and you've opened up the Intel Extreme Tuning utility, you'll see this screen here. Now I'm going to show you a couple of examples as to some default settings that I've saved. So I've talked about profiles and profile pairings, but I'm just going to run through a couple of things here. So on the home screen, you can see here it shows you the processor that you're running, and here we have the i9-14900K, which is what the example going to be using today. You may have a 13900K, or you may have another variant, and in which case you would need to pay particular attention to the default settings, and you would need to downclock accordingly based upon those. I'm running 2 banks of 16GB Corsair Dominator Titanium RAM sticks, and they are running at the XMP tweak setting of 7200 mega transfers. Now, in order to achieve scores of around 40,000, you will need to run some form of XMP. I believe from 6,000 onwards you'll be able to achieve a score of around 40,000, but don't take this as a video to show you how to achieve that particular level of performance through Cinebench R23 or any other benchmarking software. Basically, this purpose of this video is to get your processor operating at what you would expect it to run at prior to the BIOS changes, and essentially get it back to where it should be or needs to be. So I've got some options down the left hand side here. AI Assist is essentially nonsense. We're going to run it actually just to show you, but the recommendations that it comes out with are well in excess of the settings that essentially caused the problems in the first place with your processor. I've tried it just as an experiment, and I had blue screens and crashes and various other different things going on. It's essentially trying to push the processor outside the boundaries of what the BIOS update sets anyway. I would believe the microcode would be overrun by this in terms of it trying to push it outside of the maximum vid settings, but just to show you what happens and how it works, just running it here, what it does is it just looks at your existing system settings, and it will make some recommendations based upon what it believes your system will be able to run at. Now you can see it's essentially pushing the boost core beyond its 6000 rated speed to 61 on there, and then trying to set all the other cores at 59. We have the undervolt set here as stated, which I'm going to show you how to do that. It's removing the undervolt and essentially pushing all power through the processor. Intel's recommended maximum ICC max for a 14900K is no more than 400, and it's asking us to push it to 475. And then it's just putting some ratios on the cores for offsets just here, and disabling any offset cores entirely for the remainder of the P cores just here. Very optimistic in terms of its cutoff as well, so it would hit these temperatures quite quickly, I would say, and obviously then wind down any performance gain it would be making by removing the boost when the processor hits 80 degrees. I mean, if you're running a de-lidded system or something to that effect, or if you're serious about overclocking, then obviously this may be something obviously you may be able to achieve. But on a normal home user or a normal professional, I would say even user who's just running a configuration with a standard water cooler, it certainly is not something that's going to be achievable. So we're just going to cancel that, but just as I said, out of interest, just want to show you what that information contained within there shows. Speed optimizer essentially is the same. It will look at your existing settings, and it will run an optimization based upon what it believes that you're able to achieve. The one we're interested in is advanced tuning for this particular section. Now, the Intel settings are for the i9-14900K. If we were to look at the Intel recommended settings, it's 400 on the ICC max. It's different on each processor. You would need to refer to the Intel recommendations or accept the Intel recommendations on the motherboard. What I've done with this particular example is I've actually accepted the standard ASUS motherboard settings, bearing in mind that we now have a microcode fix in place, so the vid is not going to exceed the tolerances placed upon it. But what we are going to do is we are going to set the Intel recommendations for the short power max to 253. And also 253 on the long duration as well. So the actual settings specified by Intel to remain safe within the parameters are 400 on the ICC Max, 253 on short and long duration short power max, and turbo power boost max as well. Now for the example I just showed you in the recent section for the Cinebench R23 test, we had these set at unlimited, and as you can see it was previously active at unlimited, and that's essentially what the ASUS standard BIOS setting set it at. It's not going to go anywhere near that, and I think probably the maximum I've seen it achieve is probably around 260, but we are going to enforce those limits just there. And I'm just going to now apply that, and I'm going to save that, and we're going to call it overclock settings, and it will say, would you like us to overwrite the profile that already exists, and we're going to say yes, and I'm going to show you exactly why. So we're going to show you what the actual default settings are. If we go into profiles, and we go into default, and we click on show values, and we click on apply. So when you have applied your BIOS update and it has the latest microcode revision within there, if we now go back onto advanced tuning, you'll see that everything's slightly different in here now. So we have firmware velocity boost disabled, we have short turbo boost power max disabled, and we have those settings as they are just here. So we have short power max and turbo boost power max set at 253 as we just set. However, the ICC max is set at 280 as default. So this is essentially what the Intel standard settings are. You'll see, however, that the actual clock count is higher. So we'll see here that the active P core, so we see there's two cores here with stars next to them. Now these are the performance cores as they're known. So these are set at the actual default standard boost setting of 60 and 60. All the other cores set at 57. And you'll see here that there is no offset on voltage, it's set at default, so everything is back to exactly how it would be. Now what we're going to do next is we're going to leave this section and come back to it in a moment. I'm just going to show you the difference in the standard out of the box settings for Cinebench R23, and for that I'm going to close OBS and I'm going to run a standard default run on there, and I'm going to show the difference in temperatures and also the difference in performance. So we were just going to exit this and I'll come back to you in a moment. Okay, so we're back in Cinebench R23, and what I have just done before starting OBS is I've opened up Hardware Monitor just here, and I've run a pass again, which is, as you can see, significantly less than the 40,000, which is where we would expect our processor to be. Now, one of the things, and probably the reason why you're here looking at this video, is that you probably would experience when you've done your BIOS updates, the first thing you would do is to do a performance benchmark, and you're probably horrified to see that the results are significantly less than you would hope to expect from perhaps even before the BIOS update. And there's a couple of reasons for that. The main reason is that it was pushing a lot through the VID max, and it was also pushing a lot through the actual other voltages, which was causing the high temperature issues and causing the problems that many users were experiencing. Now, interestingly, with the Intel microcode revision sets in force limits, I believe that is 1.55 as a maximum. So you can see that on the maximum here we've achieved far more than what we did on the previous passes when we undervolted and we had the cores set lower, due to the fact that two of the performance cores are set to boost. And even with the performance cores set to boost, we've hit 36.565 just here. Sorry, 36.656 even, which is significantly lower. I mean, it's around 20% decrease on what we expect to achieve, and it's certainly not what we paid for in terms of expectation. Now, with OBS running, I'm just going to run another pass, actually, interestingly, to see what happens. Now, you'll notice that the temperatures have come down significantly, so obviously the revised Intel limits that have been set have served a purpose in that respect. We're about 4 degrees lower, but then the ICC max is 280 and the Intel Extreme setting on ICC max on their recommendations is 400, which is what we'll be running at. So we see here that the temperatures on one pass are acceptable. The maximum achieved here was 76 on the overall package. But still, massive issue in terms of performance, certainly not where we want to be and certainly not where we would expect to be. So I'm going to show you how to make that change to improve that and get it to where we were in the first slide. Okay, so in this final section, once again I've run a Cinebench R23 test independently away from OBS running, as we did at the very start with the other tests, and you can see again that we've got a score of above 40,000, which is essentially where we'd want to be. And did a bit of calculation actually just between sections, and we're looking around a 10% loss, between 10-13% loss on the Intel default settings versus the slight undervolt and the settings that I'm going to show you now. One of the biggest factors that determines the power issues is the Intel thermal velocity boost and the cores running at some very high frequencies. And if we just look at the vid now, we can see that it's not running anywhere above 1.4. I'm just going to reset these a moment. This is just from the pass that just did on the test just here. So you can see now everything's nice and low. We have a slight undervolt again. I've actually changed the undervolt slightly. I'm going to show you some settings on the Intel Extreme tuning utility just to finish the video off. And obviously once again you're going to have a play around with it. You're going to have to find what works best for you. You're going to have to change the settings within there, and then you're going to have to run some benchmarks. And I would certainly recommend running the stress test with AVX2 on the Intel Extreme tuning utility as well, for at least 5 minutes, and just make sure it passes before you can then move on and run any games or programs, etc. Now again, this is the settings with the changes applied to the Intel XTU application, which I'm going to show you now. So just to reopen Intel XTU, I'm going to close down Cinebench again now. We'll just run this in the background here, and we'll just put the overlay off as well because we don't need that anymore. Okay, so the default settings you may remember were settings of 57 on all cores, with the exception of the performance cores, which is on 60. Now I've made some changes here which I feel would probably best suit your system, and these settings are essentially removing any Intel thermal velocity boost, so we're not expecting any cores to work outside of the norm here. What we are asking the system to do is to essentially run all cores synchronized. Now you can also go into your BIOS and you can sync all cores, which will essentially do the same thing. I mean, once again, Intel XTU is a good way of playing around with your system and finding potentially something that may work best for you. And when you do find those relevant settings, you can then essentially set those firmly in your BIOS if you wish to do that. However, it works exactly the same way using in this application. Obviously Intel XTU is making live changes to the BIOS when we are making these changes within the application anyway. So on to advanced tuning. Now I'm just going to run through some settings here. I've set the core voltage offset to 0.55 and still achieved a score of over 40,000 with that. You may remember I was running a core voltage offset of 0.65, but just to be sure, obviously I would recommend you start off at 0.50 and check for stability on the basis of that. I'm going to just return it back to there for myself now. Now Intel's recommended settings for the i9-14900K, the ICC max on its stream is not to exceed 400, so have it set at 400 because obviously we still want that power delivery, we still want the performance. The temperatures are fine within this, so there's no issue in terms of temperatures achieved. And then just run through each of the active cores on the slider here. So if we just click on this little arrow left and right here, you can see we can set each one of them to 55, which I would recommend is a good basis for all cores to run. I've actually had, using this configuration, the highest time spy score, which was at just over 35,400, which is excellent. So it's stable, it will run everything well, it's operating at a slightly lower frequency than what the processor would normally operate at, but then it's running less voltage than what the processor would require. It's still operating within the Intel specifications, so there's no issue in terms of any further degradation. Obviously we have the reassurance that we have the latest BIOS update applied, and if you don't know how to update your BIOS, then there are plenty of reference videos out there to show you. Essentially, look on the manufacturer's website and look for the latest BIOS revision. Once you have a BIOS revision applied and the latest BIOS updated, it will revert to default, and from there on you can then utilise the Intel Extreme Tuning utility to make these changes I'm showing you here. Now you will see that there's some areas greyed out, and the reason these areas are greyed out with changes that was made previously was that Intel overclocking thermal velocity boost has been disabled. If I re-enable that, you'll see that they come back to life. I'm just going to disable that because we don't require any boosting, because all cores are actually operating at the same level. I wouldn't make any changes to the E-core ratios, there's absolutely no need, but essentially the changes that we've made, just to summarise, are there's a core voltage offset. I would recommend you start at 0.050 and work your way backwards, and then essentially apply the changes, close the Intel Extreme Tuning utility, close any other applications, and then run Cinebench R23. I'm not going to do that again for the purpose of the video. I've already demonstrated the scores. By running it again, obviously it will be a slightly tanked result once again, due to the fact that I have many applications open at the moment, including the application that I'm using to record this video. I would recommend running a stress test, and I'd recommend running a stress test with AVX2 once you've made any changes, and running that for 5 minutes, and then it will say if the system has either failed or passed it. If you make any extreme changes, it's not going to damage your system in any way. You may get a blue screen, the system may reboot, and it will just simply return, and it will set all settings back to default once the system is loaded again. And essentially the beauty of the Intel Extreme Tuning utility is that it has that safeguard built in, and it will protect your system in that respect. And as stated, if you were to make any erroneous changes within here, it will revert everything back to the default. So once again, once you're happy with all the changes that you've made, you can then click and save, and you can save. I've just changed save this one's 55 all cores previously. I'm not going to do it again, but basically I've just set this as a all core standard. There is another change that you can make if you do wish to run the velocity boost, and that is by enabling it, and then you can essentially just change the 2 cores to slightly higher frequencies just at the top here, downclock the other cores back to a lower value. So remember, the 2 cores we're concentrating on would be the ones with a star next to them, and they are your performance cores, so they are the cores that are rated to operate at a higher performance than the other cores. You can also downclock those 2 cores, and you can run the top 2 cores at a higher rated frequency, which works in the same way, but you may obtain higher temperatures by doing that. So obviously there's a reason that those cores have been rated as they are. So I hope you've enjoyed the video, and I hope it's been of some education for you and some help. And again, the temperatures running all cores synchronized and running non-boost was achieving temperatures that were essentially around sort of 7-8 degrees lower than normal. Certainly no thermal throttling issues. As said, we're operating within the parameters that Intel have set here. We're not setting anything to the 0 value or the maximum value, which would be unlimited. Everything is operating within the parameters as set. Okay, so thanks very much again for joining me, and I look forward to seeing you in the next video. And if you could please drop me a like and subscribe, just as a way of saying thank you if today's video has helped you, that would be great. See you soon.